So we were supposed to model 18 divided by 6. So we're talking like third grade modeling 18 divided by 6. What would you do? You take 18 and put it into 6 groups, right? So you should look something like that. Okay? Or circles, something like that. Nothing fancy. Okay? So when you were in elementary school and you used base 10 blocks, you remember you had one big square, then you had those long skinny ones, and then you had the tiny little cubes. You remember that? Okay, so in elementary school, the one big flat one was how much? 100. The long skinny one was 10, and the little bitty cubes were 1. Okay? Well, now we're going to change the value of those. I'm now telling you that the big one is the 1 whole. That is 1. Each one of the long ones is now a 10th. And each of these is now 100, because it would take 100 of these little ones to fill up this 1 hole. It would take 10 of these long ones to fill up this whole square. Is everybody with me? Okay, so keeping that in mind, you should already be in Braining Camp. Okay, so let's go ahead and get Braining Camp up. Now, when you first get Braining Camp up, it defaults, put this guy down, it defaults to the elementary view of ones, tens, hundreds, thousands, right? Your teacher at elementary probably has like 1 or 2 of those cubes. Remember they were like this big, kind of heavy. Okay, so at the bottom is where it says integers and decimals. Click where it says decimals, because we want to move to the decimal view. So now you can see hundreds, tenths, ones, and tenths. Okay? Okay. Let's look at our first problem that we're going to do together. 1.8 divided by 0.6. Okay, so let's write that down. 1.8 divided by 0.6. Okay, so 1.8. What do I need to pull down? Tell me, guys. 1 whole, and then 8 tenths. Now, see how I'm able to click that? Sometimes this works. Yes, I was going to say that. I'm not done counting. Ooh, why did mine stop looking? See, I said sometimes it works, sometimes it doesn't. I don't know why. Okay, the eyeball at the bottom, if the eyeball is there, you can see the numbers. If you click it, now you have to count by yourself. I don't really care, so I do find that to be pretty useful to make sure I have my total, okay? So now, what does this actually mean? 1.8 divided by 0.6. Who can tell me what that actually means? What does that mean?
That means that 1.8 is just going to be divided into 6 tenths.
6 tenths groups?
Groups of 6.
There you go, into groups of 6 tenths, okay? So I could go ahead and start right here by moving, there's a group of 6 tenths, but now, what's the problem?
We need to make more groups.
Yeah, this guy right here, I can't divide this big one because it's all together. So what you do is you click on it, maybe. Ah. Oh, I don't know how my mouse works sometimes not. Okay, if I click on there, on the right-hand side in the corner, it says break. So if you click that word break, see how it's split it into the tenths? So now I can keep building. And then I've got this one down here. Okay, so now how do I turn this visual into an answer? Well, hopefully you can see 1.8 is all the cubes on the screen. 0.6 is what? The number in each group, right? So now, how do I come up with the answer? 200. Yeah, I've got 1 group, 2 groups, 3 groups. So the answer is 3.
You know what you have to do?
All right, so now we're going to clear our board and do another one. All right. The next one is 2.4 divided by 0.6. So 2.4 divided by 0.6. Okay, so let's get that. So we need 2 ones, 4 tenths, and now what are we going to do? What are we going to do, guys? Yeah, we're going to have to break that up, okay? Because I can't put them into groups of 0.6. I can't even start that because all I have is 0.4 down here. So I need to click on it, break it up, click on that one, break it up, and move them around, okay? But look, work smarter, not harder. This is already 5 right here, right? So if I pick one up and stick it up here with that one, there's a group of 6. There's a group of 6. There's a group of 6. Oops, picked up the wrong one. And now there's a group of 6, right? So now you can circle your groups, or you could even just divide your screen, right? How many do you see? How many groups do you guys see? Right? There's just 4 groups. So it equals 4. Okay? How are we doing? Okay, so like we talked a little bit yesterday about modeling with multiplication, today we're talking about modeling with division. All right? You're right. And we're going to talk about that in a little bit. All right, so this time we've got 0.2 divided by 0.04. Okay, 0.2 divided by 0.04. All right, so this time what do you need? 2 tenths, right? 0.2 means 2 tenths. And now what? Yeah, I need to break it into groups of 400. So automatically I've got to go ahead and break these apart, right? Okay, so break those apart and then start putting them into groups of 400s. Okay. And again, if you work smarter, not harder, you don't have to necessarily move all of them around. You could just, I just kind of moved those couple, and then I was able to see there's a group of 400s, there's a group, there's a group, there's a group, there's a group. So how many groups is that? 5. Okay. Okay. All right. Questions? Excellent. Okay. So now what we're going to do, go ahead and we're going to, oh, I have to tell you guys, take out that worksheet from the other day from after the test. This one. Remember when y'all were supposed to fill in just that table? Go ahead and take that out. If you're at home, pause the video and get a hold of this. Okay, so on the test day, Wednesday, this was your homework. I asked you just to fill in the table, and I said you can even use a calculator to get it done. Then what I was hoping what would happen is as you work, then you would start to see a pattern. I was hoping that would happen, right? So over here, this is what we're looking for. Do we see a relationship between the movement of the decimal point and the number of zeros in the power of 10? Okay, I want something to do. Something to do.
I see like when you add it out of the decimal, like when it's not a decimal, it's just a whole number. The decimal moves to the right and the decimal moves to the left.
Okay, so she's saying on all of these, every time the decimal moved, see it was 2.5, it was moving to the right. But all of these, it was moving to the left. You guys see? So on 2.5, it was moving to the left. That's one good thing. There's another thing I'm going to work harder.
Every time, no matter how many zeros are on 10, 100, 1,000,
Yeah, that's what I was looking for. So what we want to write down here is we want to move the number of decimal places as the amount of zeros in the power of 10. So, for example, example, when we had 2.5 times 100, there were 2 zeros, so therefore we're going to move our decimal place 2 places, which would be 250. Okay? I sort of alluded to this yesterday. Remember with the estimating question, remember? And it was like 28 point something, and you said it was rounded to 28 times 12, and I said, do we really want to use 28? Remember that? And we said, no, we don't want to use 28. Why? Because 30 is a number I can do where? In our head. And we can use 30 in our head because we're talking about the power of 10. I don't really talk about knowing 30s in my head, but I know my 3's. And I knew that 3 times 12 was 36, right? So then 30 times 12, I just added a 0 onto that to get 360. I was already kind of talking about that power of 10. Okay? Questions about this part so far? Okay, so now let's use this information to answer these questions. Suppose you're planning on purchasing 10 items that each cost $5.35. How could we use mental math to find the cost of the 10 items? Well, we would do 10 times 535, right? So what does that mean? We're just going to what? No, first we're going to move the decimal 1 place. Now, because it's money, I don't want that. How come? Yeah, because when we put money, we need 2 places, and now I need to add a 0. Okay? You don't just want to talk about adding zeros, okay? The number of zeros tells you how many places to move. Okay? Let's look at number 2. The product of 12.4 and the power of 10 is 12,400. What is the power of 10? So what they're saying is 12.4 times something is equal to 12,400. Okay? Well, what I would say is, how did we get from 12.4 to 12,400? Let's pick up this decimal and move it. Ready? Do I need to keep going?
Yes.
Yes. Do I need to keep going?
Yes.
And one more, right? Now it matches. How many times did I move it? Did I move my decimal? Moved 3 times. So that means I need what? 3 zeros. What number? If I'm writing, you're writing. What number has 3 zeros? 1,000. So it's kind of like working backwards on that one. Okay? Can we write a rule that we can always use on the product of a number and a power of 10 without using paper and pencil or a calculator? What could we say? I'll give you a hint. Let's start with the word count. The decimal places? There we go. So count the number of zeros. And what? Uh-oh.
In the place, the decimal place.
Count the number of zeros in the, there you go, in the power of 10. Then, what?
Move that in decimal.
Move the decimal. That number of places to the right. Now, okay, question. That's the word right. What if, now this doesn't say this, okay, but what if they would ask you to write a rule if it was division? Would I need to rewrite this entire sentence? Or could I just change 2 words? What 2 words, think, What two words could I change? I see a couple people that think they know. Any more? Lucan, what do you think?
I think the first one is right to left.
Okay. This should now be left. Oh, I know why you're not coming up with another word. It's because in my previous class, we actually said multiply. To multiply, blah, 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 blah. So I guess I should put that here. So I'm going to circle, where is it? Product. Okay. So instead, that would have needed to be what? Instead of product.
So, quotient.
Quotient, there it is. If the question had said, what can we write a rule to find the quotient of a number at a power of 10, blah, 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 then we would say count the number of years in the power of 10, move the decimal, that number places to the left when we're dividing. Okay? You don't have to put that if you don't want to, I just wanted to. Okay? Okay, so now let's talk about the models and now also how to apply that new information with the models to help us, which is where you've been trying to go the whole class. Okay? So here we go. 0.9 divided by 0.3. First of all, let's put that into words. What does that actually mean? No. What does this mean?
9/10.
There we go.
0 and 2 tenths.
9/10. It's a good start. This is on the notes. So you can pick up
Divided by 3/10. Put into 3 groups. Groups of 3 tenths.
There you go. Divided into, guys, we're on the notes that you should have picked up off the back counter. Divided into groups of 3/10. Go ahead, please. Okay. So first of all, if you look at the picture, it's giving you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're giving you 10 tenths. They're one whole. That's what every picture looks like. So do we need all of those? No. What do you need? 9 tenths. So let's just shade 9 tenths. Doesn't have to be fancy, just enough to get the work done, okay? So we've got 9 tenths. Now let's do the second part. The second part says I want them into groups of 3/10. Well, so then what do I need to circle? 3/10 at a time, right? So here's 3/10. Circle another. And another. Guys, y'all don't have to shade it in all perfect. You can just do a swiggle like I did, okay? Okay, so now how do you turn your picture into an answer? Count the groups. So I see 1, 2, 3 groups. So the answer is 3. And I'm writing it up there on the top because I'm just showing that we use our model to get the answer. Notice that we have this large space for work. This is because I'm going to show you a different way to do it, okay? So 0.9 divided by 0.3. Write it down. And please write it like this. If you'll remember, a week or so ago, when we talked about all the different ways that you can see division, I said that this is one of the ways that you're going to start seeing a lot of. Okay, you're going to see this like a lot all through your mathematical career. This means divide, okay? If I want to eliminate my decimals, I don't want decimals because I want to do this mentally. What can I do with both of these? Tell me.
You can do 9 by 10. Multiply by 10.
Multiply by 10, I'm going to show you work. See, you just skip there. I have to multiply by 10, but I have to multiply both of them by 10. I can't just multiply one of them. Okay? If I multiply both things by 10, then what do you get? 9 over 3, correct? Because all I had to do was move my decimal one place. And then 9 over 3 is equivalent to 3. It's the same thing, but I was able to use my mental math. Okay? Is our answer getting bigger or smaller than our starting values? Bigger. Now I have a question. Does that seem to bother anybody else? The fact that we've started with decimals, but we're ending up with a whole number that's bigger than what we started with?
Multiply is smaller than division.
Really?
Well, we'll try this one.
I thought that if I got $20 and I'm gonna share it with you 4 kids right here, you each get $5. So aren't we usually getting smaller?
We're trying the number of groups.
Right, it's because, what are we actually talking about? Because we were putting it into groups of 3/10, we were looking for the number of groups, and then we actually ended up with more than what we started with. I just don't want you guys to get, again, this is one of those. Okay, here's the next one. Okay, so let's say it in words.
100.
What?
75.
75, what?
7,500.
100.
Divided into
Divided into, yeah. Ooh, barely had enough space. Okay, so again, let's shade in what we need. So we only need 75. So we only need 75 of those little squares, we don't need them all, okay? And now, we want to put them into groups of 500s. All right, now that I've done that, how do I turn that into an answer?
count the number of groups.
Count the groups. So I got 15. You guys get 15 groups?
Yeah, no.
Okay, so now let's do it with a little mental math here. So 0.75 divided by 500. Okay, what can I multiply them both by to eliminate the decimals?
500.
100. Now, also I want to point out, and I should have pointed this out up here. Again, notice that both of these things have to be the same, right? They have to be the same. And that's because, thinking back to fractions, as long as they are the same, what are you actually multiplying by?
No.
When these two numbers are the same, really what does that equal to? 1. And I can multiply anything I want by the value of 1, and I'm not changing its original value, right? I'm just changing the look at it. Kind of like getting change for a 20. I'm getting $21 bills for a $20 bill. They have the same value, but they look different, right? Same thing, okay? So that's important. So now, this one would be equivalent to what? 75, and then this would be equivalent to what? And so then what's 75 divided by 5? 15. Very good. All right, guys, I would like for you to try the next one on your own.
Yes, it is.
It is a little challenging, it's a little bit different. Try it on your own, if you're at home, pause the video, and then turn it back on. Okay, so first we start with 75. Okay, and now, oh, I'm gonna write this. What is it? 75.
3,500 divided into groups of 5 pets.
Okay. Did anyone find this one to be a little more difficult?
No. I didn't think that was
Okay. Okay. Oh, that's sad. Okay, so now we want to put them into groups of 5 kids. So that means I'm going to circle. I have one group. But then what happens? Well, how much do we actually have here? 25. Out of how many pieces are over here?
There's 60.
What's another way to say that? So then what's the answer? Okay, so we know that the answer is 1.5 or 1.5. So now let's do it down here with our
The
mental
model
math.
was the hardest part, because like how can I show this? I have it.
Okay?
Oh, like it.
Guys, what do we need to multiply those by? 100. So then we move it twice, so this is 75 over 50, right? And so then that would go in there, 1 and 25 out of 50 is equivalent to 1.5. Okay? I thought that one was kind of tricky. Now, super quick, I want to talk about the homework that goes with this, which is the back of your paper. It looks like this. Please listen. This, notice the word optional, okay? Because Ms. Val's made a mistake when I was making this lesson, and these problems don't really go with this whole modeling thing. So if you don't want to do it, you don't have to. It's just optional, okay?
Well, they